Hi, it's Jan Beta, and this is the Sinclair ZX Spectrum Plus 2, the initial grey version of the ZX Spectrum Plus 2, the last true Sinclair machine, I think. This is in pretty rough shape. It got donated by Anthony quite a while ago, and I figured it would be time to do some more Spectrum content, and also I want to have a look at this because it looks pretty poorly. I have no idea what it looks like inside, so let's have a look and see if we can make this shine again. Before we look inside, let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite prototype PCB manufacturer. They offer very high quality PCBs for extremely reasonable prices. They also have a service for populating your PCBs for even more reasonable prices, and they are all around friendly people with excellent service, so I highly recommend them. A link to their website is in the video description. Just check them out, and we're back to working on the ZX Spectrum. So first of all, there's actually something rattling around in there, so I am going to take a look inside. Yeah. It's going to be a good idea anyway. This is actually the first Spectrum I'm working on that has a real keyboard. None of those rubber key things. Okay, this has quite a strange way of being put together, I think. So here's the ribbon, I think, for the keyboard that I'm going to remove. And something stuck here. The heatsink, it seems. Okay. Okay, there we go. Whoa. Okay, that's the thing that was rattling around in there. A rubber block of some description. Probably to stand something off from the keyboard. Okay, this doesn't look too great, but it doesn't look broken or anything. It's just really dirty. Wow, there's the huge heatsink just flapping around here, just stuck inside here. I guess it can't go anywhere when the case is closed, but wow. Okay, there's a 7805 voltage regulator on there for supplying the board, I guess, similar to what happens on the 48K Spectrums. And yeah, the power supply should be roughly the same. Center negative 9 volts DC power supply with a barrel plug. That is the same as with the Spectrum 48K and Spectrum Plus. I'm just going to completely separate the top half here by just unplugging the tape. Yeah, that just gets rid of that. Okay. And we're going to work on this. I'm just going to go to an open window and clean the dust off with a can of compressed air. So we are going to get rid of most of the spider webs and things like that are in here. Yeah, that's a bit better. Still going to have to do some significant cleanup, but I'm just going to take the circuit board out of the case because the case needs some washing as well. It. Okay. So yeah, we can just take this whole thing out and also take the heatsink out. Doesn't look too bad actually. I think what I want to do is to replace the voltage regulator here with a beefier one, a 78. This is a 7805 CV, and I am going to use a 7805 with an S, which is a 2 amp rated version, rated for higher currents. So usually they run a bit cooler and a bit more reliable because of that. So here's my 7805 CV voltage regulator, and there's some heat shrink tubing that's really loose, and the wires are just soldered to the legs here. So I'm just removing it from the heatsink first. Whoa. stuck on there. Okay. Yeah, I'm going to add some new thermal compound on there after replacing this. Yeah, these regulators are usually pretty reliable, but they age, and sometimes they develop faults. And one of the failure modes is that they just spit out the input voltage, which in this case is 9 volts, to the output because they short internally. So that's going to destroy the system instantly. And we don't want that, so I'm just going to replace this. And I think then we are going to be safe to try if it actually works. So here it is, 78S05, same pinout, same form factor, but more current. So now we have a new, better 5-volt regulator connected. I feel confident to test this, and I am going to temporarily hook up a composite output to this. These have the same RF modulator modules that the older ZX Spectrum models have. And basically they have two lines coming in. The first one here facing here is the signal. The second one is a 5-volt supply, and ground we are going to get from the can itself, which is grounded. So we need to tap into this signal pin and the ground. The signal that's coming out of this RCA socket here is an RF signal meant for old TVs, actually, to tune into the frequency. But we want a composite signal for initial tests. Later I'm going to build an RGB cable. This actually has an RGB output, proper one. And this, I think this is an 8-pin DIN socket. And this also provides a composite signal, but I think it's quicker to just have a crocodile clamp on the signal pin there to test this. Which of course works for all the machines that have these RF modulators. Ah, there we go. Yeah, I think it's the same as on the 48K Spectrums. So yeah, we're just going to tap into there. So I'm using a yellow crocodile clamp for the signal. Then I'm just connecting this to this pin here and the other one to the ring of the RCA connector. And we should have a very crude composite mod. And I've just hooked this up to my upscaler here, which goes into the TV. And I'm using a 9-volt center negative power supply. Let's see if it blows up. It doesn't blow up, but it doesn't give me a signal. Okay. Oh, there we go. There's the signal. My crocodile clamp didn't make too good of a connection, I guess. Yeah, we kind of have a signal. Yeah, so this is what we get. It's not a proper signal, I guess. But there's a blinking thing, so something's outputting there. We're probably gonna have to make a more proper connection to the monitor. I just tapped into the composite output on the RGB output connector there, the DIN connector, and yeah, this is what we get. Much more stable picture and flickering colors on screen. Which is of course not what we want. But it's better, at least we get a clean signal now, a relatively clean signal. So one of the first things I want to try is if I actually get a reaction to the reset button. Yeah, and I definitely do. Look at that. Reset. Reset. So we get some kind of reaction. That means probably the CPU would be alright, and maybe the ULA would also be alright. We also get a border around the screen, which is a good sign. It might just be a RAM issue. Might just be a RAM issue. which would be kind of an easy fix, I guess. Let's investigate. So I sometimes get different picture outputs after restarting and warming this up for a bit. And as I said, I suspect RAM, so I'm going to poke around with my oscilloscope for a bit and actually see what the RAM does. And I have the pin out here, and I think there is one RAM chip that I suspect to have issues. So the RAM chips all pretty much behave the same, except for this one, which has a slightly wonky signal on the D-in pin, which is the data in pin, I think, and also on the data out pin. It seems very different from the others. Let me show you on the scope. So here's the data in pin from my chip, which is IC32. Here's another RAM chip with the same pin, and another one, and another one, and yeah, you get the idea. All of them have that on the D in pin, and the D out pin looks. This is the chip I suspect to be broken. This is another one, another one, another one, another one, another one, another one. Yeah, they all look the same. You could get the idea. The clocks on the CPU are alright. It seems the CPU clock looks very healthy to me. That should be correct. And we also get some activity on the data lines, and I think the processor is correct. The first thing I suspect is the RAM, which slightly misbehaves. So to verify that, I'm just going to use my old trick of piggybacking some RAM on there. And I don't even know if that's a working RAM chip that I'm using, but I'm just going to see if that changes anything. So I'm just using one of my, this is pulled from a C64, one of those MT RAM chips. This actually is a 4264, and these are 4164s, but they are the same chips, basically, just different manufacturer part numbers. So yeah, let me switch this off by pulling the plug. This version of the Spectrum still doesn't have a power switch. So I'm just going to put this on there. Like so, that's a piggybacked RAM. Let's see if the screen changes. And sure enough, it does. So here's the output with the new RAM chip, or with the piggybacked RAM chip on there. Remove it. Yeah, that's different. Okay. Yeah, that's with the RAM chip. That's clearly a different picture. With the piggyback there. This without the piggyback. We have blinking stuff. It's kind of all over the place. Yeah, with the RAM chip, it just displays a red picture there. I'm just going to put it on another one here. Yeah, that's clearly a different thing. Something wrong with that chip, I guess. So let's remove this RAM chip and replace it with another one, I think. That's going to be the first thing I do. Yeah, so that went rather well. I'm going to put a socket in to be able to replace the chip. And yeah, I always tend to socket chips that I desoldered. So I'm able to change things around more quickly without desoldering more chips. And just for giggles, here's what it does without a RAM chip in that position. And that looks very similar to what we've seen with the RAM chip in there, so maybe that was our fault. let's put another better RAM chip in there. Okay, I'm just putting the RAM chip I tried before in there. Okay, contact. And it does changes. It does things. That didn't do any good. So I did some stuff off camera. I programmed an EPROM, which is a 27C512 EPROM. You can use, I think, a 27C128 or a 256 EPROM. The ROM that I'm using is ZX Spectrum Diagnostics by Brandon Alford, who actually, when I tweeted about my ongoing repair, he pointed me to the fact that these actually can be just burned to an EPROM and used instead of the ROM that's originally in the ZX Spectrum. So that's what I did. Thanks, Brandon, for pointing that out. This also works with cartridges like the Retrolium Smart Card and things like that. Fruitcake, ZX, C3 and C4 cartridges, and detonators, and all kinds of cartridges support the ROMs provided. I have used the tape-based diagnostics before for RAM testing and used them from my DivMMC Future cartridge. I'm now going to use the EPROM I burned with the binary file provided here on the GitHub page. I'm of course going to link the GitHub page in the video description so you can make your own. So as I said, I have the EPROM inserted here instead of the original ROM, which I took out, and I'm just going to power this on now. Let's see, it should test the lower RAM, and judging by the screen corruption we got, there is several RAM faults in the lower RAM, which is also used for the screen RAM. And yeah, as you can see, it clearly and very subtly points me to a RAM fail position 4. So yeah, it's kind of obvious that RAM at position 4 failed. And according to the manual that is also available on the GitHub page I am going to link, on this particular model of Spectrum, it is this chip that is RAM 4, IC28 in this case for the Spectrum Plus 2. And yeah, I'm just going to desolder this and put a socket in and put a new RAM chip in and see if that fixes our problem, and then run the diagnostics again to see if there's more broken RAM chips. It might very well be that there are several broken ones. Yeah, I tested this with the scope in the meantime off camera as well, and our the behavior we got, the wonky trace we had on the scope is better now with this inserted. So I hope, maybe, this one might be the last one we have to replace. Let's see. Okay, let's try that again, shall we? Oh, test card. That looks a whole lot better now. Yes. Diagnostic hardware not detected. Okay, that's okay. We don't have any diagnostic hardware, but at least it works as a RAM test. Now it seems we need the keyboard really. Oh, it's assuming the 48K mode at least. Okay, nice. Yeah, sorry for the terrible picture quality. It's, yeah, I'm going to show you in a second how I have this connected. But it seems like at least the 48K is completely good. That's pretty nice. So maybe this is fixed. I'm just going to hook up a keyboard and do the other tests. So don't try this at home, but this is how I've actually hooked up the monitor to this at the moment. I have this, my so-called PokeBit, an ale, I think, is the technical term for this. I have this stuck into the DIN connector, which actually holds pretty well. Got the right diameter, and I have the ground hooked up to the can of the RF modulator. I'm going to make a proper cable, I promise. But for testing and for hopefully fixing this, this should be enough. So let me see if I can attach the keyboard here in any reasonable way. I have no idea if the keyboard works. But we're going to find out, I guess. So I'm just putting several pieces of paper here in the hopes this is insulation enough. Okay, let's try and power it on. Starting our diagram again. And this time we hopefully can press the correct key for the Spectrum +2, which is key number 3. Okay, now it should run should test all the RAM actually. RAM banks, yeah, it's testing multiple RAM banks now, that's good. The picture looks horrible, I'm sorry. I'm going to make an RGB cable for this thing. Cool, okay, that seems to have worked. It seems to have passed the RAM tests. That means no more bad RAM, probably. Very likely no more bad RAM. I don't know how accurate these tests are. Sometimes you have some bad bits still, but yeah, this is very, very promising. Let's just see if we can do any other tests. Oh, now it's doing, okay, I have to hold down the keys while starting up. Now it's doing the ULA test. Interrupt test. Movement should be smooth. Nice. Test border generation. Test screen switching. Oh, that's for the 128K. But this technically should be compatible with the 128K. Should. Yeah. Test ULA port addressing. Flashing green porter passes, anything else fails. Okay, flashing green. We don't have anything hooked up to the ports, so we can't really test the mic and ear port. Hold brake to exit. Okay, let's do the soak test. Holding down S. Does that do anything? That's probably the RAM test looping. I know that from the tape version. Upper and walk test. Yeah, it's doing the iterations of the test, and it's just testing 48K RAM in the soak test mode, I think. Oh, okay, that's the test card. We don't have the sound hooked up, so I can't test the sound. What's the keyboard test? Okay, there we go. Yeah, it only has the 48K Spectrum keys there. Hey, but my keyboard, at least the keys that are present here seem to work. That's nice. Okay, that's our about. That's the latest build, it seems, from 2018. From Brandon Alford's PC, it says. The host for the build was Alford's PC. Interesting. And Dylan Smith is the other, I think the original version is from Dylan Smith, and Brandon expanded the diagnostics. Pretty nice. Yeah, this seems to be a fully working ZX Spectrum. It's not in the best condition visually. And the picture quality from my admittedly bit improvised composite cable is not the best quality. But hey, Seems to be a working system. I think I want to put the original ROM back in there and see what that does. Did I ever mention how much I love these this chip puller? I'm going to link that in the description again, because it's such, if you are pulling chips on a regular basis like I am, these things are invaluable tools. They are so good. Jonard tools. Hold on a second. Jonard tools. Oops, okay, there's my cable disconnecting. We have a startup screen. Pretty nice. This is like stuntman programming with a keyboard that's not even properly connected. And a video cable that's not a video cable at all. Okay, there we go. Okay, can I run this? No, not like this. Run. Yay! Scroll. Scroll again. Gotta love the Spectrum. I actually do love the Spectrum. Yeah, after some more thorough cleaning of the expansion port or cartridge port, I actually managed to get this to run my DivMMC Future. And I'm now playing Voltage, as you can see. And it appears to work fine. I even have a little speaker hooked up to the audio out, and that works, so we have audio. This seems to be a fully working ZX Spectrum. And of course, obviously, I have to do some more refurbishment work on the case, especially cleaning. I have to put new capacitors in this, of course, as I do. And I also have to, I think, turn around some of the transistors that are in here in the wrong direction from factory, actually. I have to look that up and read up on that. Hopefully this is going to be another video with an even more satisfying outcome. I'm quite satisfied that I got this to work at all. And yeah, thanks to the brilliant Diagnostics ROM, it was kind of a piece of cake to diagnose this. And yeah, thanks Dylan and Brandon for making the diagram. I'm going to link everything I used in the video description, and I hope you found this informative, hope you enjoyed this, and I hope to see you on this channel again. Thanks everybody for supporting me on Patreon and on the channel memberships page. I'm Jan Beta, thanks for watching, see you next time, bye!